Okay, so this is the promised video on stoichiometry free response 2003B. So when we read the problem, the first thing you want to do, because when you get your, on the AP, you're going to have a mixture of problems, and so from lots of different topics, so you want to recognize what it is. So this is labeled for you, but it's not like that on the test. At any rate, here we go. Answer the following questions that relate to chemical reactions. Iron 3 oxide can be reduced with carbon monoxide according to the following equation. And so, the equation. A 16.2 liter sample of carbon monoxide, this is a gas and they just gave me a liter, so I'm already clued in. At 1.5 atm at 200 Celsius is combined with this many grams of iron oxide. So we're going to rewrite our equation. So this is, we're going to label this A, and we're going to label it I, okay, because that's what we're working. We haven't even got there yet, but we're fixing to rewrite this. FeO3 plus 3 CO2. Keep yourself spaced out. And 2 Fe plus 3 CO2. All right. I wish I could write neater. Okay. Now, I'm given information that I need to record because it's going to help me figure out where I am. So they told me I had 15.39 grams of this, and then they gave me information over here. I have information on the amounts of 2 starting materials. I am in the land of piv inert, and I hadn't even read the question yet. 1.50 atm. I'm in the land of piv inert, yes, but I'm in the limiting reactants is what I was meaning to say. And not 200 degrees Celsius, that is 473 K. So 473 K. I can take this information and go to moles. I know I have to do that. Just going to have to happen. And I'm going to have to get this in moles as well. So, brief read of the questions. 1, how many moles of CO are available? 2, what is the limiting reactant for the reaction? Justify with calculations. 3, how many moles of iron are formed in the reaction? Okay, so first things first. So I would relabel it down here. Anyway, so I ask for moles of CO. And so you're going to say PV equals nRT, and N is equal to, I need my 0.0821 atom likes, oh, what was that? Atom likes, what does atom like? Chocolate milk. Well, he likes milk. Atom likes milk. And so that times my temperature in Kelvin. This was the point that was offered for that substitution. Oh, man. And then I've got to divide that by the volume they gave me and the pressure, which is 1.50 atm, and 16.2 liters. Do the math, plug it in your calculator, cancel your units out, and you come up with 0.62. I need to write that better. That is equal to 0.626 moles of CO. Box your answer. You've got to have that, and you've got to have that. So you have a unit and a substance. So that's A. Done. I mean. Double I. If you do not label your problem the parts right, they will not grade it. So heads up. What is the limiting reactant for this reaction? Okay, so in the past you learned to do the limiting reactant so that all you did was take what you were given and figure out somebody. You picked one of the products and you said, well, how much is this going to give me of that? And how much is this going to give me of that? And then pick the least, and that's the limiting reactant. That still works. However, there's a shorter way to do it. And I showed you this in that video. I don't know if you watched it, but I'm fixing to kind of teach you a different way to do this whole business. So I'm going to take, and just for the purpose of figuring out, if that's a 2 and that's a 3 and that was a 2, I'm going to rewrite this just for the purpose of figuring this out. Plus 3CO, and it's going to yield you 2 Fe plus 3, oh man, I don't know why I keep doing that, CO2. Okay, so I'm going to write here, I'm going to write the moles of what I have. So moles of this, I need the moles of the iron oxide. So how do I get that? Well, that's going to be 15, and you want to do this, I wish I had could spread my paper out, but I can't. So do you want to do it in some orderly fashion? Grams of the Fe2O3, and the molar mass is 159.7 grams in 1 mole. And you can do all of that, or you're in Big Chem now, and so you can just slap one on top of the other. That's a G. Fe2O3. And what do I mean by that? It is perfectly legal for you to do this now, not last year. And call that done. And put your answer there. Okay, so you don't have to go through this whole process. You can do it like this if you like, but you must make sure it's neat and not like mine. Okay, so I'm going to erase this because I just need to get some room. So we go to the side, we figure out, or you go down to the bottom actually, would be better. To go underneath it, and I can do that. Look, I got a paper extender. Oh Lord, we ran away. Where are we? Come back. Come back. Where'd you go? Oh Lord. I'm sorry, guys. I'm not any better now than I was before. I don't think I'm ever going to get better. But, yeah, well. Okay, so when you did this math and you got the moles, we came up with, how many moles did we come up with? We came up with 0.0964 moles of this. And you already know that we have 0.626 moles of that. So this is like table form. So read across. So column, 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 row, row, row. All right? And what's your mole ratio? Bring it down, 1 and 3. So now you have to, for just this step, I want you to divide your moles by your mole ratio, and you're going to come up with a number that's going to tell you who runs out first. So if I do this, then I come up with 0.964, and this ratio is going to give me something like 0.209. That was a 0.0 right there. Okay, from this, you pick your limiting reactant, the least. This. That's it. So this is your limiting reactant. It is going to run out before this one does. Okay? That's because I divided it by the molar, each number of moles by that coefficient, their own coefficient. Okay? Now that you've done that, you have identified the limiting reactant. Okay? Scratch the rest of this. You don't use this part for anything else right now. So, here's how I want you to think about this. I want you to think about, and you don't have to do it my way, this way. It's not necessary, but if I can get this cleaned up, it's going to be a lot easier and you're going to like it. Okay. And your answer is yes, of course. Except that now my other computer's all messed up. Okay, what are you doing? Are you erasing? Okay, good, good. I just wanted to erase the line. Okay, I'm going to go put this back. That was a 3. Okay, so what did I do? I simply wrote down the number of moles. I divided the moles by their own coefficient and picked the least. So that gave me my limiting reactant. Okay? So what I know to be true is that I'm never going to use all this. That is not a real deal. Okay? I know that now. So here's what I'm going to do. Now I'm just going to get rid of this, but I'm still going to keep my table because I'm going to do something else with it. I'm going to show you a really super duper cool thing. So that's the down and dirty quick way to figure out your limiting reactant, all right? But now let's go take it a step further. So this equation says 1 mole of iron oxide combines with 3 moles of carbon monoxide to produce 2 moles of iron and 3 moles of carbon dioxide. Okay. So in the nitty-gritty, I have 0.09 moles, 64 moles of the iron oxide. This is my 1. This is all I'm going to get. This is my balance. This is my 1. So for every 0.0964 moles of iron oxide, I'm going to get 3 times as much, or need 3 times as much carbon monoxide as this, what I'm given. I wasn't given the whole blessed mole. And then from here, I can produce 2 times as much of this iron. Okay? So these are moles, not grams, moles. So I will produce 2 times as many moles of iron as I have iron oxide. I have 0.0964 moles of iron oxide. All right? So now I can tell you that, so does that make sense? I hope so. Also, I know that this 0.626 or 69626 moles, I'm never going to use it all. How much am I going to really use? 3 times the amount that's my 1. 3 times that amount. So what is 3 times this? I'm only going to use 3 times this. Well, actually, let's just do it this way. Maybe this will make more sense. How much of this am I going to use? So this is going to be 0.0964. That's how much of this I'm going to use, 0.0964 moles. I multiplied it times that. This. I'm going to take this number and I'm going to multiply it here. So times the 0.0964 moles, that's my 1. How many of these do I need? I'm going to come up with like 0.289 moles of this. That's all I'm going to use. I have this much, but I'm only going to use this much, right? Because my 1 is this amount. Another way, anyway, so I'm just going to keep going this way. So then here's my 2 for my coefficient, and I would bring this down 2. So 2 times whatever was my 1, this is the amount. So 2 times the 0.0964, that's going to give me some 0.19 moles of iron that can be made. Okay? And so I could do the same thing and figure out what the 3 is. Well, guess what? Here's a 3 times that amount. I'm going to get 0.289 moles of the carbon dioxide made as well. Okay? So Since this is the one and it's my limiting reactant, I didn't have to do anything different. This is my 1. So 0.0964. I'm going to erase up here a little bit, and I'm just going to re-talk you through this again. Because this is sort of a pretty important idea to get you, once you get used to it, and to get you some speed. Okay. If you get this, rock on. Go finish with the rest of the video. Fast forward. Okay. So that was my 1 because my coefficient here is 1. And it is my limiting reactant. That's my 1. 3 times that amount. That's how many moles I'm going to get. These are moles. So I'm going to only use up 0.289 moles. The rest of it's going to be sitting there. And 2 times that same 0.0964 moles, I'm going to make 0.19 moles of iron. And because I already did this one, I know I'm going to get 0.29 moles of CO2. Now they can ask me whatever they want to ask me, I got the answers. Okay? So, you just have to figure out what your 1 is. And so, in your balance, anytime you do an equation, okay? So, could you do it the other way? Yes. The other alternative for you to do the other day was to simply say, what's the limiting reactant for the reaction? And you would have said, okay, they gave me, you would have gone from grams of the Fe2O3 to moles of Fe2O3 to your molar ratio, and then 2 moles of the Fe. And then when you did that, you would come up with something like 0.19. And then you would take your moles of CO and, not CO, moles of carbon monoxide, and then you would do your molar ratio, and you would figure out, because you would just have to pick one you were going to go to, and then you would figure out how many moles of iron you could produce. Well, this is going to be like 0.4 something or something like that. So this was your smallest amount, so you should have done that. What maybe you didn't understand to do, and that's part of this learning process, is how to answer this question. What is the limiting reactant for the reaction? So just to do this and check this and say this is the limiting reactant does not suffice. This requires a sentence. Sentences. Justify your answer with calculations. This is your supporting information, but not your answer. So, having all of this down here is absolutely justifying information. Doing this is justifying information. But you must say it clearly, because, and here's the language that you need. So own this language. You're going to need it, all right? Blah, blah is the limiting reactant. So I need more room. Patience is a virtue. And patience is a virtue. And I would be a virtuous person if I had some. Oh, Lord. Am I even on the right thing? Where's my problem? There we are. Excuse me. Okay. Now, so we would write, I don't know what those buttons are. Sorry. Okay, so we want to tell them up front in their face. what is, now remember we're still on 2, right? So this would have been a nice sheet of paper, and it would have had the number, the 2 thing up here. And you would say, up front, tell them, Fe2O3 is the limiting reactant since, and this is where I use this information, this is why this is more useful than doing it the other way, because you still got to think your way through all the other stuff if you don't do it my way. But you have to talk about molar ratios, how much you're given and how much is used. This essentially, what does this essentially mean? It means that only, over here, that I am going to only use up this much. I'm going to use this much. I'm going to use this much. I'm going to make these. I'm going to use 0.829 moles to react with all of that. So this is how much CO is required to react with all the iron oxide I have. At the end of the day, I could tell them how much I have left over. I started off with this amount, and I'm only going to use this amount. So if they want to know how much is in excess, I can tell them that is my excess CO. That's not enough to answer this question. This question says, what's limiting reactant? Prove it. Well, I just did this. So since 0.289 moles of CO, that's your excess reactant, is required to completely react with the, how many moles was that? 0.0964 moles of Fe2O3 available. And, or you could probably figure out a better grammatical way to say this, or but 0.626 moles CO is available. Therefore, actually you don't write therefore, you just put the therefore sign, triangle dots. Let's reread that. Fe2O3 is limiting reactant since 0.029 moles of CO are required, are required to completely react with the 0.094 moles of your limiting reactant available, and there are 6.026 moles of CO2 available. Therefore, CO is in excess. And restate it, Fe2O3 is limiting. Okay, so what are the important parts here? Tell them what the limiting reactant is. Box it. Since, and here's where you're going to describe, you're going to write. Let's get a formula. Since this is going to be blank moles of whatever you have in excess. That's your excess. Other. The other one, not the limiting, the other. Are required to, keywords, completely react with the moles of your limiting reactant that are available or provided. and you have this many moles of the CO available. That looks horrible, but you get the meaning, I hope. We can work on that, but I hope you get the drift, because I'm going to run out of time. I haven't even finished the first half of the problem. Okay, so now where are we? Pause. Okay, so here we go. We are going to answer... Oh, I guess we're recording. 3. So this is A. That will be 2I. I need to move my screen. Oh, what happened? Oops. Let's see. Okay, you just go ahead. And I don't know what I'm doing. There we go. Alright, so the question here was simply how many moles are formed. And so you can write, it was 0.19, I think, 0.19 moles Fe formed, and draw a loop back up here. That's where you did your work. So that is proof enough. But if it's sloppy like that, you wouldn't want to do that. You would want to say, just take it and just very quickly, because you've already figured it out, just prove it to them. Moles of Fe 203, and do your molar ratio, and you have 1 mole of this, and you could write it out like that. But now if you've written it really neatly, and I hope that we get the opportunity to practice that, to 2 moles Fe equals the 0.19 mole Fe. But if this isn't as neat and legible like this isn't, then you don't have to rewrite it. You can just arrow to it and show your work. That's what's the beauty of this, is because sometimes another question would be, how much is in excess, or how much of that is formed, or how much of the carbon monoxide is in excess. So, or remains, or they may not say the word excess. They may say remains in solution, or remains in the vessel. But you would have to be able to go back and figure out that excess, and this is how we did it right here, in case you got lost. Okay, so we get to practice this all over again, because the next part of the problem says, so B, so we're finished with A, so we're moving on to B. And I'm going to clear this nasty screen. It's all gone. Yes. Okay, so B. In a reaction vessel, 6 moles of barium nitrate and 3.3 moles of phosphoric acid are combined with deionized water to a final volume of 2 liters. Guys, I've got moles, I've got liters. Somewhere I know these liters are going to be important to me, or they wouldn't have said it. All the information, you're going to let the problem lead you. One thing leads to another. Pull out your information. So you need to say volume over here is 2.00 liters. Write yourself out some notes, and you're going to have some moles all together. How many moles do you have? 0.6 and 0.3 of each of those things. So altogether, you've got some 0.9 moles in 2 liters of solution. So that's a concentration. All right? So just start keying in on that. But the important part is this, right there, so you remember it. All right. So the reaction is represented below. Calculate the mass of this that is formed. Well, guess what? What do I have? 0.6 moles and 0.3 moles. Given the starting amounts of 2 materials, I am in the land of limiting reactants. So how much of this product am I going to form? This is my question. What mass? They wanted that in grams. So let's practice doing what we just did. So we're going to rewrite our equation. 3BaNO3 taken twice plus 2H3PO4 yields Ba3PO4 taken twice plus 6HNO3. Okay, so I want moles and I want molar ratio. So how many moles do I have? I have 0.6 moles of the barium nitrate, and I have 0.300 moles of the phosphoric acid. And so who's going to run out first? Well, I'm going to divide both of these. Here's the mole ratio, the coefficient. That's a 2. And to do the down and dirty quick limiting reactant identification, I am going to program this thing to not jump so far on one page turn. Oh, come on. Okay. So, to get my limiting reactant only, and then I'm going to erase it. Limiting reactant, I'm going to divide those two, and here I'm going to come up with, 0.2. And then I'm going to divide the other side, and I'm going to get 0.15. Hold on. So this is going to be 0.15 when I divide those two things. So check, who's the smallest? This one's the smallest. So this is my limiting reactant. Okay? I just did a molar ratio comparison, and I know that based on using a 2 to 3 ratio, 3 moles of this to 2 moles of this, I am going to run out of the phosphoric acid first. It's the 3 to 2 ratio, the ratio divided by the amount that we're given. Okay, because this is like for every 3 moles of this, I need 2 moles of this to produce 1 mole of this and 6 moles of this. Well, we don't have just the plain numbers, so we make that adjustment. Okay, check. We know our limiting reactant. That is our limiting reactant. Now, we're going to use that information, and we're going to figure out what our 1 is, okay? So, if this is what I'm going to run out of first, I'm going to run out of this one first. But so if this is 2, what would the 1 be? If I put it all on a level playing field, because this one goes away first. So the 1, my 1 in this reaction is going to be that half of that. So it's going to be 0.15. Okay, if you don't understand that, don't worry, it'll get better. Alright, so for every, so if this is 2, then let's play across this way. So this is 1. This is 2 moles of phosphoric acid for 1 mole of barium, of this barium phosphate. Okay, 2 to 1. If I have 3 of these, and for every 2 of them I get 1, then, or half of it, so I'm going to get 0.15 moles of this made. Okay, because I'm going to use all this up. It's my limiting reactant. So now can you see that this is 1 because the coefficient is 1. So my 1 then, here was my coefficient. So my 1 then is going to be the 1.5. This is 6. So how many, I'm going to get 6 times as much of the nitric as I have of this. So how much is that? Well, whatever 6 times the 1.5 is. And then, so 0.3 is 2. So how much of this barium nitrate am I going to use anyway? This is excess. I have a limiting, so this means this must be in excess. So what is that? How much is in excess? Well, I have, I need 3 times the 1 amount, okay? Or you could do the proportion, but it's easier if you do it this way. So the 1 amount is 3, so I'm really going to use 0.45. That's how much I'm going to really use. And I'm going to really use all this, and I'm really going to make all this, and I'm really going to make whatever 6 times that is, 6.15. And so 6 times 0.15, 6 times 0.15 is 0.9. So I'm really going to make 0.9 moles of this. Alright, is everybody cool? So I'm really using this amount. This is how much is required or used. I started with this amount. How much do I have left over? How much of that? So that's going to be, you just subtract it. So 0.6 minus the 0.45, I'm going to have this 0.15 excess. That's left over. Okay, that's going to be left in my pot. Okay, and so now, what do they want to know? I know how much I'm going to use, how much I'm going to make. What else they want to know? And my excess. They want to know the mass of this that's formed. So 0.15, this is I, 0.15 moles of Ba3, PO4 taken twice, and the molar mass of that, we have to go add up, big hunker number, 602. Okay, so 1 mole of this and 602 grams of that in a mole, and I get my, there's a 3, there's a 2, and I'm going to come up with 90.3 grams of Ba3PO4. There you go. Now, you could have done this the old-fashioned way, the way that you've been taught initially, where, and it's all cool if you're comfortable with that. That's great. Doesn't really matter. You take the amount of this that you're given, that would be your 0.6 moles, and you pick one of the products, and since we would have read down to the next question and we saw that, you figure out that. And then you take this one, and you had 0.3, and you figure out that, you pick the least, and you then going with the least, converting that least, you would have figured out the mass based on that phosphoric acid calculation, because it would have been your least. Now, I calculate the pH of the resulting solution. Oh, what was that? The pH of the resulting solution. So, pH, so solution, right? Oh, what am I doing here? What is all that? Undo. Okay. So pH is equal to the negative. These are notes I'm writing, it's not my problem. That is, because, oh, what is that? Well, it's on the formula sheet. So now I need the concentration of the hydrogen ion, and it says in the resulting solution. So what is in my resulting solution that's going to cause that pH? That would be my nitric acid. Okay, so pH of the nitric acid. There's II. So pH. Okay, SCIS for pH of that resulting solution. And we said that that resulting solution came from A3. So what I need to do then is figure out the concentration of that HNO3 so that I can get the concentration of the hydrogen ions, because pH is equal to the negative log of that hydrogen ion concentration. Okay, so how are we going to do that? Well, we have 0. First of all, we need moles. What is concentration? It is moles per liter. And remember, I told you earlier that those liters were going to come back to us. We were going to need them. And if you look up, that was 2 liters. 2 liters. And we figured out that we have 9 moles of 0.9 moles of that nitrate. So 0.9 moles of the nitric, that would be the home formula, and in 2 liters of solution. And so that's going to, I wrote ammonia, HNO3, yay. Okay, so we have 0.9 divided by 2. So our concentration is 0.45 moles per liter of the HNO3. Okay, so they would expect to see how you calculated this 0.9 moles, and so you should notate for them that you calculated that up here, or you should rewrite it neatly. Either way works, but only if, only do this arrow business if in fact it's, it's legible. But this, this is fairly legible if you could read that that was the 0.515. So, because your work should be pretty clear about what you did. They're smart enough to figure that out. And so now, so this is the concentration of the nitric, but we still need the concentration of the hydrogen ion, and we get 1 mole of hydrogen ions for every 1 mole of HNO3, and it's a strong acid, so it all breaks apart. So we're going to get 0.45 moles per liter of hydrogen ions. So then we simply have pH as the negative log of 0.45 moles per liter, and then that means your pH is, I think, 0.35. I don't know. That doesn't look right. What was your pH? Yeah. Negative log of 0.45. So your pH is 0.35. Pretty low. Box your answer. Okay, so the last question, and the end of this video, that it seems to have taken an eternity. What is the concentration? Why do I'm touching something wrong when it does that. I'll figure that out one day. Okay. What is the concentration in moles per liter of the nitrate ion, NO3, after the reaction reaches completion? Okay. We went a long way around, but never, ever, ever lose sight of the fact that this entire thing is a limiting reactant problem. So when they're asking you that, don't be fooled into going back and just picking up the nitrate from this. Because remember, you had a limiting reactant. It was this. What did you have in excess? This. That was your excess. That means you have excess nitrate. right? Excess nitrate. How much is excess? Well, how much did you not use? You used 0.45 of the barium nitrate, 0.45 moles of this in your reaction. So you had 0.15 moles left over. So how many moles of nitrate ion are in the 1.5 excess in the 2 liters of solution? So you're talking about a solution, and it said in liters, and whatever you have is going to be in 2 liters. Okay, so you have 0.15 moles of the BaNO3 taken twice in excess. And from that, you get, from every 1 mole of this, you get 2 moles of nitrate. Don't forget that. That's important. So you have 0.30 moles of nitrate in your 2 liters of solution. So what is then your molarity? Why do I have a different answer? Because I'm on the wrong page. There we go. No, wrong answer. Wrong. Well, is it the wrong answer? Or am I going to get the same thing? We'll find out, won't we? It's the wrong thing. Whoa. Okay. So, I don't really know why that won't work. I'm going to pause you. Aren't you happy? Okay, so you just watched your teacher fall for the trick in the book. This is the problemo. Alright. So, yeah, this was a trap. I fell in it. Alright, look. Look at this. All nitrates are soluble, right? Yep, they are. So, all of this nitrate, some of it went over here. But even if it's over here, it's still floating around in the solution. And the part that didn't get put over there is still floating around in the solution. So all the nitrate is still floating around in the solution. So it's all soluble. And it's nitrate, they're all soluble. So everything you put in it is still floating around in the solution. Okay? I saw that the first time. I forgot I saw it the first time. Yeah. Okay, so all the nitrate that we put in there is still there, and it's all in nitrate form. Okay, it didn't fall out as a precipitate. It's all still floating around in there. So however many moles that is, 0.6 moles is what we started with of the barium nitrate, 2 moles of nitrate for every mole of the barium nitrate, all in 2 liters of solution. So we can do that. So 0.6 moles of the barium nitrate and 1 mole of barium nitrate. You have to show this molar ratio, by the way. This part you do have to show when you're doing something like this and you're getting a 2 to 1, like I showed it up here. They want to see that you know molar ratios. They're all about some molar ratios. And 2 moles of NO3 minus for every 1 mole of that. So that's going to give us that 1.2 moles of NO3 minus in 2 liters of solution. So the concentration in moles per liter is 0.60 moles per liter NO3 minus. Whew. Okay, took an hour to do that problem, but I hope that you learned a new skill in that, and I hope that you will practice that and ask questions. And I want to tell you that when you're doing your multiple choice questions, and I put some practice up for you, and I gave you an assignment this weekend to do, when you're doing those, you need to pay particular, what did you do? You need to pay particular attention to these molar ratios and use a handy little table like this, knowing that, because they'll give you simple molar ratios or something you can quickly get to moles with if it's a mass. And you're doing a multiple choice, it's a mass, just round it up. So you're going to round, and you're going to try and make really good use of these molar ratios and this mole business, and knowing how to bounce based on your coefficients. Okay, so that's a really big tool in working those multiple choice questions. So give it a try. Please post questions if you have them, and I may come back and do another video later, but no promises.